So last time we understood how this turning moment diagrams you can have for different types of engines. So a single cylinder engine and three cylinder engine and so on. So you understood this. So now you also understood that the flywheels prevent the components from failure, early failure, because they actually reduce the torque fluctuations by taking up the inertial torques. And you also understood that most of the strokes suck the power out of this. So these are actually the formulas. So next topic is about the different types of flywheels and the radius of gyration. Guys, here flywheels feels like simple disc, and if you suppose if you look at these two guys, you can imagine the size. These guys maybe it is actually an expo where they're actually trying to sell a flywheel. You may think, what is there in a flywheel? That's just a disc. Okay, maybe it's a high-speed flywheel where you need to rotate this at some high speeds, and the balancing is so well that even if you rotate it, the flywheel doesn't produce any imbalance. It's not that easy to have a completely balanced flywheel. So you can imagine this, making a flywheel is not easy. It has got a lot of manufacturing issues also. And what you're seeing is this large flywheel. You can see the size of the flywheel looking at this ammonia. This flywheel has gone into a scrap yard because usually this type of flywheels were used in early 19th century for steam engines and single cylinder engines. And now they are no more used, so those flywheels are gone waste. So now we are trying to understand the radius of gyration. So radius of gyration, I just said that if it is a disc type flywheel, so if it is a disc type flywheel, so did you observe, guys, basically, did you observe which is a disc type flywheel and which is a ring type flywheel? This is not exactly a disc type flywheel, so this has got mass here also, but it is slightly grooved in. It's not exactly a disc. And here you can see this is a rim type of flywheel where you got spokes here, and most of the mass is concentrated on the periphery. So when you've got a flywheel something like this, then you can say that the radius of gyration is here because most of the mass is along the rim. So what is radius of gyration? Radius of gyration is an imaginary radius where you can imagine the mass to be stored, which actually feels the same in rotation. Okay, so you can imagine this to be the radius of gyration. But this type of flywheels, which are actually this type of flywheels, they need to be imagined this way. Okay, a solid disc, this whole mass can be placed at an imaginary radius, where that imaginary radius k is equal to r by 2. So that means if this radius is 100 mm, then this radius of gyration, that means that imaginary radius is 100 by 2. So what is the use of this k? Now this k can be used in finding out the kinetic energy stored in a flywheel. And you can see there was a question in Indian Engineering Service examination which said what is the value of the radius of gyration of a disc type flywheel as compared to the ring type of flywheel for the same diameter. So it is, the answer is B, which is 1 by root 2 times. Somebody writing any other PSU examinations here? Anybody preparing for that? No one. Very rich people here. Guys, you can see here, this radius of gyration k can be used to find out the energy stored in the flywheel. Find the kinetic energy of a flywheel when it rotates at 10 rps. Now what is the flywheel size? The flywheel is a solid circular disc flywheel which has got a radius of 300 mm and its mass is 20 kg. So what is the energy stored in it? Now to find out the kinetic energy stored in it, kinetic energy formula is what? K is equal to half I omega square. What is I? I is nothing but mk square. where m is the mass, which is actually 20 kgs. What is k? K is actually radius of gyration. Radius of gyration for a disc type of flywheel is r by root 2. So radius is 300 mm. So 300 mm divided by root 2 will give you this. So this can be used to find out k. So then k square multiplied by mass, that will give you moment of inertia I, and the units is mass kg. This is meter, so it becomes kg meter square. So units for moment of inertia is kg meter square, and this kinetic energy is like half I omega square. This is kg meter square, 0.9 kg meter square. Here it is I omega square. So here omega, it said that it's 10 rps. It is already in radians per second. So you know that one round is nothing but 2 pi. So 10 rounds is 2 pi into 10. You don't have to divide by 60 because it is already in seconds. So many rounds, radians per second squared. So here there's a second squared. So what you are left with is kg meter per second squared and one more meter like this. So this kg meter per second square is newtons. So Newton into meter. So this kinetic energy has got a unit of Newton meter, the same as torque. Because energy is what? Okay. So how do you define work done? So what is the formula for work done? So work done is defined as the force applied through a distance. It is the same thing. Force applied is Newton, distance is meter. So kinetic energy is the ability of something to do any work. So the unit is same as Newton meter, which is the same product of force into distance. Okay, like this. And then we have, I think it's the same thing for, I think if you're interested, if you're really interested in engineering, then the formula for this I is equal to half m square, and all of this for different symmetry can be given here. So anyway, I am actually providing this in the notes, you can look at it. But here for our syllabus, they only have this type of flywheel and rim type of flywheel. This type of flywheel, I is equal to, K is equal to R by root 2. For rim type of flywheel, R is equal to R itself. Guys, suppose if you had some unique shape which was not disc, which was not rim, and some unique shapes of a component which is rotating, and you wanted to find out the moment of inertia, then you can use any software and you ask for the moment of inertia. That will give you moment of inertia about all axes, x-axis, y-axis and z-axis. Okay, it will calculate the values for you. Okay, so you don't have to worry about it, suppose you are using a software. Otherwise, you just need to fit this. I just said that there are two types of flywheels, this type of flywheel and the rim type of flywheel, and the radius of gyration has to be found out like this. Again, it's getting repeated. And this, have you played with this? You can make it. Okay, but don't, I think usually it would be with this mint type of mint chocolate. It used to be that these days I have seen. I think it's very dangerous because that mint would actually break at any point of time. If you're doing this, it would come and hit you. And I've seen this, like, I think it's very dangerous. I don't know why they actually make it out of mint. So they have done it so that once it breaks, people can hit it. So like this, so you know how to do it. So initially you try to rotate it. When you actually stretch it, it actually starts unwinding. As it actually starts to unwind, it actually gains kinetic energy. And as it gains kinetic energy, it won't stop. Once it unwinds, it starts rotating in the other direction, and then it again winds in the other direction. Again you stretch it, unwinding in the other direction, it keeps going like a pendulum. It can't stop because you are actually trying to apply these forces. So this is almost like a flywheel, and suppose if you have got bigger and bigger disc, then you will feel more resistance to stretch it and also release it. Okay, so this is like almost the effect of the flywheel. It stores energy. So this is the same. So let us see what is fluctuation of speed. I think English meaning. What is fluctuation of speed? Increase in speed and decrease in speed. So fluctuation of speed is the maximum speed minus the minimum speed. But what is the maximum fluctuation of speed? The difference between the maximum and the minimum speeds is called as the fluctuation of speed. I think sometimes people get confused, but it's just term. That's it. Fluctuation of speed is difference between maximum and minimum speed. Suppose if the engine is now revving at 1000 rpm And if you actually observe throughout the cycle, at some point it increases speed to 1010, and at some speed it actually decreases to 990. So that means the fluctuation of speed is 1010 minus 990, which is actually 20. So that is actually fluctuation of speed. And then what is coefficient of fluctuation of speed? So coefficient means, so it is the maximum fluctuation of speed, that is the difference in the speed divided by the mean speed. What is actually mean speed? Mean speed is sum of the highest and the lowest speed divided by 2. So all this you should remember. So maximum speed plus minimum speed divided by 2, that is mean speed, and fluctuation of speed you know. So that is omega 1 minus omega 2, where 1 stands for higher speed and 2 stands for lower speed. So this is what is the mean kinetic energy. So mean kinetic energy is actually half I omega square, where omega is the mean angular velocity. So what is the fluctuation of energy in flywheel? So the fluctuation of energy in flywheel is the variation of energy above and below the mean torque curve is called the fluctuation of energy. The difference between the maximum and minimum kinetic energies during the complete cycle is known as the maximum fluctuation of energy. Of course, you will have various cycles, and at some point, like you will have some highest point where you will have the highest money in your account. There is a point where you will have the lowest money in your account. Like that, these flywheels will have highest energy at some point, that is usually after the power stroke, the lowest energy that is at the beginning of the power stroke. Like this, that will give you the fluctuation of energy in the flywheel. Then what is actually the coefficient of fluctuation of energy? Coefficient of fluctuation of energy is actually the maximum fluctuation of energy to the work done per cycle. So these definitions you should remember. So basically the previous definitions are easy to remember, but this has to be remembered. Coefficient of fluctuation of energy, that is maximum fluctuation of energy to the work done per cycle. Okay. So this coefficient of fluctuation of energy, should it be larger or smaller? Suppose if you are an engineer and suppose if you are trying to design something, do you want to keep this fluctuation of energy larger or smaller? If you want to keep it smaller, you will see that the fluctuation of energy in the single cylinder engines are 0.21, but fluctuation of energy in cross compound steam engine, or you can see this 6-cylinder engine. 6-cylinder engine is almost like 10 times less, because 6 cylinders are working one after the other, so fluctuation of energy is less. Okay, if you got 6 incomes, then your account balance will almost stay the same, because you are spending and there is so much of money flowing in. So your account balance is huge, so it will not vary much. So derive an expression for, okay, this is an important question, guys. Guys, I am telling you, please write this. Don't ask again. Please tell me important questions. It is an important question. Please write this. Derive an expression for maximum fluctuation of energy. Derive an expression for maximum fluctuation of energy. What is the time now? 55. Okay. I think just 2 minutes we'll finish this. Okay. There are an expression for the maximum fluctuation of energy. Guys, sometimes it can actually confuse you. Fluctuation of energy means what energy we are speaking about in flywheel? Will it store chemical energy? Kinetic energy. So we are speaking about fluctuation of kinetic energy. So kinetic energy is, what is the formula of kinetic energy for rotating parts? Half I omega square. So half I omega square is the formula, but here we are speaking about higher speed energy and lower speed energy. So if you want suppose if you want the maximum fluctuation of energy, so that is maximum kinetic energy when you got the highest speed omega 1 and minimum kinetic energy when you got the lowest speed omega 2. So you can write it as omega max if you want, you can write it as omega minimum if you want. But 1 refers to max and 2 refers to minimum. So half I omega square is the maximum kinetic energy, omega 1, and if you substitute this as omega 2, this becomes the minimum kinetic energy. When you write this, when you actually take this half I omega common, now this becomes like this, omega 1 square minus omega 2 square. I think this is similar to a square minus b square. A square minus b square can be split into a plus b into a minus b. The same thing that they have done here, a plus b into a minus b, and you already know that omega 1 plus omega 2 divided by 2 will give you omega. So you can divide this and you can substitute this omega here. So you are left with here half I omega, and here this omega 1 minus omega 2 divided by omega, one more omega you can add, you can actually divide by omega and multiply by omega, that becomes omega square. So now are you getting this? Divide by omega and multiply by omega, one omega comes here. And this omega 1 by 2, so omega 1 plus omega 2 divided by 2, again one more omega comes, so that becomes omega square. So this can be written, so you can add omega 1 to compensate the square here. So then finally what you are left with is, this is an important equation for solving numericals. You should know this equation. Most of the numericals are solved with this equation. So this delta E, which is the fluctuation in kinetic energy, is given by the formula I omega square multiplied by Cs. I think, do you know what is the Cs? Cs is what? Computer science. Fantastic. What is this, man? This is what? Difference in, is it kinetic energy or speed? This is fluctuation in speed divided by the mean speed. That is coefficient of fluctuation in speed. CS is not computer science, CS is coefficient of fluctuation of speed. Okay, so you can actually substitute this mk square if you want, then you can actually do this. So you can actually work on this equation and get different equations to solve the problem. So this equation is very important in two ways. With this you can solve a lot of numericals, and also this equation, the derivation also comes in the examination frequently. Okay.